All right, good morning. Thank you for having me. Let's see if I can make this work. I'm invited. Great. There we go. All right, I'm Dr. Neil Thompson, University of Maine at Fort Kent, Associate Professor of Forest Management there, and also the co-principal investigator at the University of Maine Spruce Budworm Lab with Dr. Matt. I also seem to be the unofficial photographer of this event. I'm behind the camera and everything you see here. So my students and I have been working on Budworm together since 2018. Before that, I earned my PhD at the University of Northern British Columbia, studying the outbreak history of Western Spruce Budworm. Before that, I graduated at the University of Maine's forestry program. Had the opportunity to learn from some faculty who worked with this last time. So I'll be taking you through some details of Spruce Budworm life cycle, some of the landscape context of what we're seeing in Maine today, and some results from this year's early intervention strategy spray program. We'll start the life cycle with the L2 dispersal stage. This is the little guys you see on my fingertips here. This is the stage that wakes up in the springtime looking to eat. It went to bed without feeding last summer and wakes up trying to find its way into the bud just as it begins to swell. That's why we call it the budworm. It wants to feed on that poorly defended, very nutritious food source and start its season eating the buds from the inside out. So it's already made its way in there, eaten that, and then it's looking for another one now. As the season goes on, the needles emerge. The budworm is feeding in a more exposed condition. It's vulnerable to predators, parasites, and the Maine Budworm Response Coalition. As June goes on, they go through the stages of life. The first, second, third, fourth, fifth, and sixth larval instars. Each instar takes anywhere between 3 days, super warm, or a couple of weeks if it's super cool. But on average, about a week per stage of life. They're feeding on balsam fir, on white spruce, on red spruce, Norway spruce, black spruce. They will occasionally fall down onto a pine tree or a tamarack or something else and take a bite, but that is not their preference. You see the characteristic 4 white dots per body segment, 1, 2, 3, 4. On that, that is the budworm. You'll see some other things feeding around the same time that has lines or different shapes, not the same thing. And this is an L6 final instar larva about to go into the pupation stage. We have 2 more of those, 6 instars here. And this one, you see that swelling behind the head. It's just starting to go into the pupation stage there. And this gives you an idea of what the color you're looking for is. You're not looking for the bright red that you might see with a root disease or a beaver flowage. That is that dull reddish brown color that lasts for a few weeks in June and July. What that is budworm's a messy feeder. It will clip needles off and not eat them, and the needles get hung up in the webbing. And that just holds on until the rain washes them away later in the season. So if you're seeing that red color in June and July, think budworm. If you're seeing bright red any time of year or bright red later in the season or this time of year, something else. For an idea of scale, here's a few of my little buddies from the 4th to 6th larval instars. And my students are used to hearing me say my buddy the budworm. And pupation stage occurs in late June. It lasts a week or 2 depending on temperature. Everything depends on temperature. There's variation in color in both pupae and the moths. You see some that are more gray, some that are more red, sort of like grouse, blue-faced and red-faced. The flights take place mostly in the evening. All of these that you see moving up here, if you can, those are budworm moths flying on my neighbor's woodlot in Fort Kent this year. So it's a pretty good year for them to go through their life cycle and lay eggs and fly. They adaptation to lay some of their eggs where they started, anchoring the population, and lay more of their eggs somewhere else, spreading the population. The self-powered flight is about 25 to 30 miles. But if a storm is moving through as they're flying in the evening, they can be picked up in that storm and transported for hundreds of miles. So I've seen some maps that have those long migration distances. That's assisted migration by the wind. But this is just them moving around. They're going to be doing some mating, egg laying here, and then moving somewhere else. Very handy adaptation for them. At point 0, this is the most intense defoliation category that you can have. This is complete loss, not just of this year's needles, but also of this year's shoots. Everything has been consumed. Everything that you see from here back, that's last year's shoot and last year's needles. this is a healthy but hatched egg mass that the larvae have already left. They hatch out within a week to 10 days. And at point 2, we have a healthy egg mass. There's a parasitic wasp that will lay its eggs inside that, and you'll be able to tell because that'll be black instead of white. It'll eat them from the inside out, and that's a good thing for us. And then at point 3, you can see the little black heads of the larvae just about to emerge. And yes, I am proud of these photos. This is a very initiative. And these are some tiny, tiny little guys. So this took a bit of doing here. They're green at the first larval instar. So they've gone out of the egg. They go to bed without eating, but first they have to find a spot to do it. And that is some little crevice in the bark, a bit of lichen, an old pollen cone scar or something. They weave what's called a hibernaculum with silk that protects them for the winter. So they disperse. If you've seen Charlotte's Web, you know how this works. A little strand of silk comes out the rear end and they float on the wind. I saw one this spring during the spring emergence where it was floating along, hitting an updraft, and flew right back across the border into Quebec. Yes. So they find their spot to overwinter, and this is the adaptation that helps us the most because we have this long window of opportunity to forecast next year's population before it does end eating. This is a large part of my work, helping to organize the foresters and collect some myself. This is one of mine. And what you do is collect branches from the mid canopy, which is where they tend to be, and collect this 30-inch branch and send it down to the good Dr. Mack, who runs the Spruce Budworm lab. And this is a service center, the only one of its kind in the nation, based on our colleagues in Quebec, in New Brunswick, and using technology that was developed in the 1970s to separate the larvae from the branch in their overwintering condition. So what we're able to do is soak them in some very fancy scientific equipment called 5-gallon bucket with some sodium hydroxide, separate the larvae from the branches. And then these fine folks are able to count them. So we have 3 full-time employees, 11 undergrads at UMaine, making a significant career step as their first lab position for the most part. And we've grown from 292 in 2021 to 930 and counting. And thank you very much, Angela, for delivering 9 more this week. So we continue the process as we learn more about where the population is. And over the past few years, we've gone from less than a half a larvae per branch. How to get half a larvae? To upwards of 1.5 per branch. So we're seeing increased population as well as increased sampling effort as we hope. So this is on the UMaine lab. It's out behind Nutting Hall. Now, bit of landscape context here. This is research year 2013. These are data points that come out from a budworm processing lab. Each one of those is an L2 site. And those feed a model that then calculates these areas based on all of the nearby points. So this is research year 2013. It is predicting or forecasting the feeding of 2014. This is the most powerful tool we have that allows us to predict where the feeding will occur next year based on where they're spending the winter. So in 2013, we see a large population on the North Shore. In 2014, it's just about as heavy on the South Shore. And this is the point where we can contrast the 2 management strategies of Quebec and New Brunswick. Quebec is taking a foliage protection strategy approach. That is like Maine did in the 1970s and 1980s. That's where we consider the horse to be out of the barn. And we're not going to try to impact the progression of the population. That this is millions upon millions of acres here. And millions upon millions of acres are not going to be sprayed. But we can pick out 1 or 2 million acres that we consider to have a high economic value and protect those. And that is the idea of a foliage protection strategy. Keep economically important trees alive until we can go get them, or until the outbreak naturally passes on. In New Brunswick, they've taken a new approach that was a dream back in the 70s and has become a reality with modern technology and data. And you see a higher density of L2 survey points here. And the idea is catch it early and treat it small. That's the early intervention strategy. Every health issue is better caught early, and this is no exception. That if you can treat the population when it is small, a relatively small spray program in the scale of hundreds of thousands of acres can be a relatively large proportion of the whole. And this is where you have the opportunity to actually affect the course of the population. This is not an eradication strategy. You can see it continue to exist, and it is based on what's called the eruption threshold. That is the point beyond which the natural enemies are no longer effective in maintaining the population. Talked about the egg parasites before. We'll see some other parasites soon. So moving on, 2016, we see some movement, some ebbs and flows around Maine's border. But anything that we're getting from Quebec is going to be a long distance flight and necessarily dispersed by the time it gets here. What we see in 2019, besides some rough days in Quebec, is this movement. So ignore all that. That's all distraction, please. This is what matters. That's their problem. This is becoming our problem. So this is the possibility of short range migration flights across the border. I said before, they fly 25 to 30 miles on their own. So there's a huge difference between a long range dispersal flight from there here, which can happen, and this one, which is hard to map, but very easy to comprehend once you see how it goes. So keep an eye on that area right there. 2020. This is research year 2020 and forecasting the population of 2021. This is where early intervention strategy starts in Maine. This is a small and privately managed and funded program, about 5,000 acres, but this is where we start to get our feet wet. 2021, little program out here, tiny spot out there. Quebec and New Brunswick are still going full tilt.
What year was that? Sorry.
That was research year 21 and program year 22. 2023 for us was quiet. 2023 was not quiet for Quebec, but again, that's their problem. 2023, again, a small incursion across here that drew about a 6,000 acre response. And then we get into the current or most recent year. Now let's neglect Quebec here and let them sort it out and move on to our own view here. So this is the University of Maine's Spruce Budworm lab data collected by dozens of foresters and a bit of my own work. And this is essentially that short range migration from Quebec into Maine. So white is 0, green is 3.5 or up to 3.5, essentially don't worry about it. Yellow is start to worry about it, and red is getting into more areas of concern. So we see a large area in the west and a hot spot in the east. Now let's just skip ahead and focus on points for now. So we had points here that were in the 60s, 80s, 90s, 114 if memory serves. And as I said before, this is not an eradication program. We're not trying to get rid of the thing. We're just trying to bring it to the point where it is contained by its natural enemies. Mission accomplished. So we have a large reduction in this area here. We've gone from 104 down to 4 at one site, from 90 something down to 3 at another site. This is the goal. We have some spots, and we'll take these by their category in a moment. But at a broad landscape scale, we have a very good effect from our treatment program, which is the outlined area in black here. You'll note there's areas showing through here. That's buffers on streams, wetlands, rare butterfly habitats, and a few camps that drew some buffers. And you'll see a pretty marginal coverage right along here. And then the woodlot country here. I'm sure the Maine Forest Service will tell you about the hard work they're doing to make the program available to the small woodlot owners, but it was not last year. So this is overlaying our current year. And I can just do this for the next 20 minutes and be perfectly entertained. But so we have a few spots that grew out here and a few new spots, and let's take them by category and acreage. We have about 5,000 acres that would be eligible for retreatment. That is what was treated last year, is eligible again this year. And we have a few things going on. I think this is just short range migration. Flying up this border, it's red out that window and green out that window. So I think I know what happened here. Pretty low counts, but good. Here and here, the points happen to fall right next to stream buffers. This one went from, I think, 94 to 8, but you'll have some stuff moving around and the natural enemies aren't perfect. So we just see a few spots here and there, but I'm not personally worried about that. And then what I suspect is going on here, this is some short range spillover from the untreated woodlot areas. So I spent a good bit of time right up there. I saw a good bit of red, and I'm going to show you a picture in a minute. That it was a good year for survival in the untreated areas, so they were able to spill back over, and that's where the landscape scale approach is illustrated. So we had 6,000 acres eligible for retreatment. We have about 35,000 acres that were eligible last year, were not treated, and are eligible again this year. There's this spot around Maybeck Bridge. I collected the sample both years from the same trees and got exactly the same number. So there's a few spots here and there, but mostly what we're looking at was a lot of the woodlots would have been eligible last year if we had that opportunity, and they are again this year, and these folks are making that available. So about 35,000 acres get back here. And in green, we have the new areas. We have a few spots in the west, Madawaska Lake here. So we were doing a bit of an overflight there and looked out the window. What's that doing down there? We got a point right about here and a point right about there, and both of those points had a count of 3. And then in the middle, it's red. Interesting. So I get up there, I kiss the ground and realize I'm not built for airplanes, and get back to my real position on the ground and go out and find out that would have been a count of between 30 and 50 if we had had a point there. And that's the nature of the beast. It's a spotty event when the populations are early. So that's developed, it's spread, and now this area here is eligible, and I expect that will be handled this year. We have a similar story out here as well, looking at the defoliation patterns. I think we have small patches that were intense and do what budworm does. It's an interruptive insect, and it will grow given the opportunity. The opportunity seems to have been good this year. But before moving on, like I'm missing the whole story here, bearing the lead. You don't see massive spread from the treatment area. That's the goal. That early intervention strategy is designed to identify early, identify before feeding happens, but more importantly, identify before population spread happens and contain it where it's found. I was also tasked or asked to go out and make sure the product did what it says on the tin. It did. And I have a lot of Shakespearean death poses of budworm. And this is an insecticide that's got to be, get back here, it's got to be consumed by caterpillars to be effective. It's effective on any caterpillars that eat it, but it is a short window of action, so there's only so many species that are feeding at this time, mostly budworms. So it has to be consumed in a certain quantity while it is fresh. These ones have done so. This is the same caterpillar on both sides, so it is consumed, treated foliage here, received its lethal dose, and perished. Now, there are areas where we could not treat. These are stream buffers, as we should, 100-foot buffer on streams. And there's also situations where at roadside, you have branches down here and branches up here. The branches up here catch the spray. The branches down here don't have any. So that's where I got that nice photo of all the larvae in my hand. So, I don't know, you know, they're always going to miss some. Well, they didn't. This is the cleanup crew. On this side, each one of these white dots is the Egorynthemia parasitic fly. So just be glad those don't go for humans, because black flies are bad enough. They lay their egg, and then the maggot bores inside, eats the caterpillar from the inside out. Now, there's 7 of those on here, which is a bit much. But what I saw is one or two of these per caterpillar, sometimes 1 every 2 or 3. And then over towards the Frenchville area where there was no treatment, 1 spot every 20 or 30. So you're taking a certain population of these parasites and distributing them among the caterpillars that survived the treatment. So what this is showing me is that in situations where we're seeing every other caterpillar get parasitized, oh, this is a pretty good ratio of parasite to host. And this one, I hatched a Glypta fumiferana. It's a budworm specialist parasitic wasp. And that's more of the cleanup crew. The rest of the cleanup crew would be birds, and we love them and the work they do. There's about 500,000 acres of our landscape that is between 1 larva per branch and 3.5 below the eruption threshold. The birds and the parasites and other predators are what define that threshold. So that 500,000 acres is just birdworm. And I mentioned before, these products wear off. So this is a black-headed budworm, eastern black-headed budworm, and we expect to see 1 or 2 per branch. And what I was taught is we just expect to kill them in the process. They're not interruptive species in this region the way the budworm is. It's there, it's interesting, we're gonna kill it with a spray, and that's it is what it is. We get a bit of bycatch. But this year, I'm wandering around a bunch of treated stands. That one looks fine. And what it is the life cycle is staggered by 2 or 3 weeks. So BTK lasts between 3 and 7 days in the field, the tetrafenicide about 30 days. This is a little less than that, but it seems to have worn off as advertised. So that reduction in bycatch over our previous assumptions based on the old chemical processes is a big win. So we have products that are not affecting the natural enemies, a big win, and wearing off as advertised, allowing the other species to complete their life cycle. Now, this is about as severe a defoliation as anybody's seen since 1986-ish. This is the Fish River Falls Trail. The rest of you come up and visit Fish River Falls Trail, come see what severe defoliation looks like. All this webbing. The caterpillars have eaten everything they had up their original feeding site and went down looking for more. It's not like forest ant caterpillar will wander all over the place looking for food, but when they finish up their meal, they'll drop down looking for more. This is the site that you see in your handout. We have a home, an untreated buffer on a home, and a treated area here, and an untreated area on a small woodlot up there. This is the same site from a drone. Not showing up terribly well, but well enough. This is the treated area, the road here, and the untreated area here. Same site, different perspective. Treated, untreated, that's 1 year of severe defoliation. And I would expect, and I think we're already starting to see some mortality in that stand. So we are at the point in Fort Kent where we're going to have some trees dead. Question.
Does severe defoliation kill the tree?
It depends. I'm sure if you've been to any forester talk, it depends is your default answer. So a healthy tree that is otherwise dry. Balsam fir can usually take about 4 years of moderate to severe defoliation. If the tree is otherwise stressed by high competition, as it is here, drought, as we had 2017 to 2022, and still seeing recovery from that, there are interacting variables that would cause that change. So we have some situations with stressed trees that are infected with other diseases already, where we expect to see death. And then also where you see absolutely complete defoliation plus back feeding on the old needles. That's where, yeah. And there's areas that have already seen 2 or 3 years of defoliation. So yes, there's going to be some trees where cause of death is budworm. So Quebec, Maine border, pink clear cut, green, light green, hardwood ridge, softwood valleys in green on our side and in red on the Quebec side. That was impressive flying at the border. This is a false color image made with some color infrared spectrums turned to what's more intuitive to the eye. But I can tell you flying up that line, it looks just the same. There's red out that window and green out that window. Now I'll finish this up with a story if I have time, and I hope I do, because this, I think, illustrates just where we're at in terms of budworm response. I was invited out in 2024 to tour some defoliation that hadn't, the sites weren't treated. And it was a site like this. This is an old budworm era salvage cut. And it is grown up in a mix of black spruce and balsam fir. And the landowner invested in a pre-commercial thinning, brush saw work back in the 1990s, spacing the trees out. You start with this dog hair mix and you put them on a 6 or an 8 or 9 foot spacing, 6 foot back then, 9 foot now. And this sets it up to be ready for its first commercial thinning in another 15 or 20 years. And that has occurred here. So we've had a pre-commercial thinning with a brush saw. We've had a commercial thinning where forest products are harvested. And then the trees start to take on a reddish tinge. And we go out and tour a site and my daughter's asked me, are we gonna need to salvage this or pre-salvage this? Because that's of course the thought process of last time. This is the ultimate endpoint for bloodworm infestation. And it's no. That the early intervention strategy is one, designed to prevent the need to treat most stands. That if the population is treated early and contained where it landed from the in-flight from Quebec, most stands aren't going to need treatment, but those that do are protected. The momentum is maintained, the growth is maintained, and that's what we're seeing here. This was treated, I believe, this past year, was not treated the year before and had some. If anybody doesn't like these trees, we can have a conversation later. But these are beautiful spruce that are, they've got another 20 or 30 years ahead of them. We don't have to cut off that plan. Investments have been made in the next generation's wood supply. Those investments can and will be realized through this program. So preventing the spread of the population protects most stands by reducing the need to treat them at all. But then these thin stands, my message has been, you don't need to stop thinning. You can continue. It will improve in many ways the response, but we don't need to cut off these investments before their time. This can continue to be a beautiful stand, end up being some beautiful logs and some beautiful homes in the end. And it is of zero concern. And looking back on that 2 years later, I still believe that absolutely, that this is a treatment that works. It is a treatment that prevents the need to sell the stands which have received investments. There's other stands where it's just wall to wall balsam for it didn't happen. I treat that with a chainsaw or a feather buncher or what have you. That these are potential sources of population that aren't bringing much benefit in terms of growth at this point. But these ones that have investment, these are how foresters, loggers, and scientists have been preparing the wood supply for the next generation, and that doesn't need to be cut off. So it's persistent work. We're 5 years and a bit into it, and New Brunswick is 10 years, 12 years and counting. Every success so far. So I think we'll do questions at the end. That's all for me. Thank you very much.
Greatest thing about that presentation is Neil had some slides, which means I can skip over some of mine, because his were better. So just a reintroduction, I am Alex Ingram, day job, president of Pingree Associates, large landowner in the state of Maine. As I mentioned earlier, my other job and other hat right now is the Maine Budworm Response Coalition Chair. We are a membership of about just under 8 million acres now, Krista, I believe, for MBRC, and represent large landowners. We're working with the state of Maine and the Maine Forest Service for small landowners to help implement early intervention strategy, which we will hear about in the talk after me. And so I'm going to talk a little bit about 2025 activities. Neil covered the science. I'm going to cover logistics and operations. And so what we did last year in the program, how we succeeded, and what we're kind of expecting next year. Neil provided a great introduction in terms of what we're looking at from an acreage standpoint, and I'll talk more on the logistics front. Also, Neil mentioned he's the unofficial photographer. These are both his photos as well. Because he takes way better photos of Spruce Budworm. There's some intermixed here that I'll take credit for, but Neil does a better job of photographing bugs. All right, so we've seen this. This is what we were dealing with last year when we talked to you in January of we have an outbreak coming. We're going to start early intervention treatment. This is the final interpolation map that Neil and Angela and the Spruce Budworm Lab were able to put together for us. As you can see, large areas of concern, over 300,000 acres total that could have been treated, and we treated 242,000 acres. I believe the specific number is somewhere up here on the graph. 241,793 acres would be the exact number that were treated last year. The key to treatment, and Neil mentioned this, is having good data. And good data comes from the Spruce Budworm Lab, our foresters, from the entire cooperative and throughout the entire state of Maine, collecting branch samples to send to Orono to get counted to see how many of those L2s are on the branches that give us this eventual predictive model to show where there's a problem and where there is happily not a problem. So going to what we ended up for a treatment plan last year. And this is an example of our logistics map. So all these red squares, these are staffed locations for when we were actively treating to make sure that no one was passing into those areas. This swath, we were able to shut down for the entire portion of the treatment, ensure that there was good public safety. It was 1, 2, 3 control points, so very easy to manage logistically. This year will be a little more challenging because we have a bunch of spots and all over. Over here, logistically a little different. All these green ones are temporary shutdowns, and these are permanent spots. And then that little orange dot was a automated sign that kept everyone up to date on that front. So this is a lot of planning that goes into this. This took 10 months to come up with this plan. This took a ton of effort on the advocacy side and a ton of effort from our Congress members, particularly Senator Susan Collins, who worked very, very closely with us to come up with the funding to make this all possible. And thank her again for this coming year is in process. We're waiting for signature on the final bill, which passed on Thursday or Friday. So big thank you to Senator Collins and of course all her staff on this. It has been a really exciting thing to see. And when we came to them last year, when it was all of a sudden, oh, we have a problem. How do we deal with this? We put together this organization in very quick order. So what did it give us? It gave us this map, and it also gave us the treatment plan that we were able to implement. So fast forward to, we are now a week in advance, 2 weeks in advance of a potential treatment plan. So what instigates the go moment? When do you start actively treating? It is all down to what does that bud that Neil was showing earlier with when they're starting to actively feed. You want that spruce fir needle to, instead of being like a closed fist, you want to start seeing the fingers start peeking out. That means the foliage is about to pop. That means you can get good application onto the foliar area, which will allow for ingestion by the insect. And so this was our tool built in cooperation with, based off of a Canadian survey 123 model. Mike Parisio from the Maine Forest Service did an awesome job crafting this into something that we all could use. Everyone pooled resources and data. So all these sites are across 7 different landowners and are all being collected daily. And in some cases, once in the morning uploaded, once in the afternoon uploaded to see on a warm day what the difference was. Stunningly enough, 2 hours of intense heat and sunlight, it changes a little bit. Sunlight does wonderful things to trees. We like sun and rain. We grow more timber, but also make a little more insect food at the same time. So with this tool, we were able to see, okay, once it hits bud stage 4, there was a 6-stage scale or something. Thank you. Good. That is the optimum time to start. So when you start seeing 3, 3, 7, and it getting to 4, you're close. The only thing that's going to slow you down is cold weather, rain, something that operationally isn't going to be feasible, which we experienced and got us through Memorial Day weekend as well. So we started the program. We did a test run right before Memorial Day weekend, just before optimum, to make sure all equipment's functioning the way it is. Treatments are looking good. We had excellent efficacy in those areas as well. And then the day after Memorial Day, we began treatment in earnest. And this tool allowed us to do that. It probably drove our contractors a bit batty because it was like, we're ready, we're not ready, we're ready, we're not ready. But we ended up going really at the perfect time, and weather played a great deal of help last year. So this is us looking at those little L2s. Sorry, Neil, this is not your thumb. This is my thumb. I took this photo. And there's Neil looking at the buds. So little live action shots of the process, and we enter that into our phone on the app. And from there, we're able to get that uploaded. We had Mike, Brittany, and Neil all looking at the buds to make sure that what everyone was saying is the right stage was correct. So every single sample was reviewed by an entomologist. And that really, really helped get us to a point where everyone was comfortable with this is the time to start treatment. So that brings us to active treatment. Over those 10 months of planning, we worked with our contractor to help organize a small fleet of aircraft. We had 8 fixed wing aircraft and 3 helicopters as part of the treatment program last year for the 242,000 acres. An aircraft, fixed wing was covering about 1,200 acres per flight. So very efficient time frame wise. A helicopter was covering, I think the most productive helicopter was covering about 3,000 acres per day. One of these aircraft on its own could cover, if you got enough flights, almost 8,000-9,000 acres in a single day if the weather cooperated and conditions were all right. So what are conditions have to be? Too much rain, bad. Light rain, okay. Wind above 10 miles an hour, no. So you have to have these perfect conditions. You have to meet that across a 500,000 acre landscape because we're flying out of Frenchville and we're treating the border on Quebec. So you need people on the ground. You need people to be radioing in what the conditions are and making sure everything is optimal at all times. So really quite a feat of logistics, and this little command trailer right there was where everything was being monitored at once. So active treatment, we were flying over the planes that we're actively treating. And the reason this is flying over the same stand, but what I really want to point out is the high accuracy of this treatment. So you can see a steady stream behind this plane treating those acres. And then right here, when it gets over hardwood, it cuts off. There's a very hard line, and that falls onto the softwood and not onto the hardwood because we don't need to treat any acre that isn't necessary because that costs money and we want to be fiscally responsible. So another vantage point from the ground, because I was one of those people out on the ground for a couple of those days because you have to monitor the silos where there might be people to make sure that all safety measures are being followed. And so I brought along my camera and got to snap some photos at the same time. So they're flying very low to make sure that there's good efficacy and the chemical is hitting the targeted area and targeted species that we want to treat. So very, very impressive to see this operation in action. So what are the results? So we treated 242,000 acres with both tebufenicide and BTK, depending on the area and the prescription and what was needed in those areas. The total application cost came out to about $45 an acre, as we mentioned last year when we were talking to you. And we got federal reimbursement for 90% of the cash cost of this, and then 10% covered by the landowners. And in-kind contributions are estimated at 20 to 30% above that from landowners like myself and others in this room that contributed a lot of time and effort into this project. What did we see? Well, year-over-year reduction in L2 counts, which is our true measurement of success, with a little interference from flights, as Neil mentioned along the border. We saw a 94% reduction in L2 counts. So this is what the dollars brought. Good success. We did not eliminate the population, as you saw on the previous maps. There's still that natural level of the population within these areas, and that is exactly what we want. And what we also built was a successful blueprint for how to do this for years to come, modeled off of New Brunswick, flavored with our own way in Maine. And so that was a really, really successful outcome. And then part of that is public communications, really crucial in this process. We held plenty of informational sessions, starting with this one last year, and then with a forum about a month before the treatment started, and a ton of communications in the county with groups and local folks in that region. You've seen this. This is just a closer in zoomed in version of Neil's photograph, but pointing out the spruce budworm areas that weren't treated versus the areas that were. Really good example of how effective this was. Neil's photos are way less blurry than mine because I had to zoom way in. So this is the Fish River from Fort Kent to Soldier Pond. This is an area that was in that untreated bucket, basically right up and following this corridor, and one of the hottest zones in the outbreak in the valley. So you can see these brown, reddish colored trees in here. These are all defoliated last year. This is a small woodlot owner's plantation that has been very defoliated. You can see intermixed ones all throughout here. Some of this, like right along the river corridor, we did a 4 times the legal requirement for a buffer zone to just make sure we're being extra responsible. And so that's some of that would not be able to be treated anyway, because it's within the 100-foot zone. But everything back towards that gravel pit could be treated. So let's look at some of the areas in Quebec. As Neil said, if you're flying down the border and you look left, or up the border as the case may be, you look left, this is what you see. A lot of gray. This has been defoliated for multiple years. You just see Maine on the horizon over here, and this is all Quebec. It's hitting hard across the border. Some good news is they did do some of their foliar protection strategy last year in their worst locations, which does help control the moths' migration into Maine. So that was a nice assist by Quebec last year. So hopefully that's part of the reason why we didn't see as much inflights and spillover across the border, because they were treating those areas that had been doing that in the past. So what does land in Maine look like? Pretty good. A lot of green trees, a lot of healthy trees, a lot of healthy forests. You will see some in the riparian zones, anywhere where there's a stream corridor where we're not treating. There is some gray. Some of that's natural just because it's older, more decadent wood that's not being managed. And some of it is a beaver flowage right here in a cedar swamp. But looking particularly right in this area, in this riparian zone, a lot of that is budworm feeding. But outside of that, in the managed forest, very green, very blurry because I zoomed in. So I need to get a faster camera. Or tell the pilot to slow down.
Yeah.
Another photo I borrowed from Neil. So that's kind of the wrap on the 2024 to 2025 life cycle. So now we're moving into 2025 to 2026. And so we start by looking at moth flights, those long dispersal events that happen every year. Last year there was a really big one. This year, not so much. There's a couple that are concerning, but you'll see in a moment. There's some big ones that go up and away from us or out to sea. We like when budworm becomes fish food, supports a different industry. And so those flights, we are highly encouraged of the wind to carry them out into the St. Lawrence. That is a great outcome for us, but some of them did fly into Maine along the Route 11 corridor. Sampling does not show that there is any issue arising from that yet, but certainly some areas to monitor. So this is one of our monitoring tool sets of tracking them, and it's because these moths fly in billions of moths, and it shows up in Doppler radar as snow in July. So if you want nightmare fuel, that's it. So looking to 2026, borrowed this slide from Angela. Angela, if you're still online, thank you. So this is the overlay of what was treated last year. Neil had a very good overlay of this as well, so I won't belabor this. But as you can see, most of the zones that need to be treated or could be treated this year are outside of what we treated last year, which shows good success from the program. So looking at 2026 L2 data collection, this is what drives the EAS program and how we select what should be treated and what should be left alone to the natural predators. A few little areas that have cropped up, some new ones in this region. A repeat customer over here because of moth flights, probably from Quebec. That point that Neil mentioned, but all in this area, really good efficacy, good results, to the point where our second largest landowner in the program last year has 0 acres this year. So some really stunning results that we have seen. So very encouraged. Over on the eastern side of the state, we still have in the valley, and Maine Forest Service is working with small landowners to start building a program there for folks that wish to treat and deal with the incursion of insects. And then this new one right there that we talked about earlier with Neil. So pull all the points off to just give you an idea of what it looks like on the landscape. These areas are all scheduled for treatment. This area and quite a bit of this area, and adding as many acres as small landowners want through the Maine Forest Service program and the funds that you all helped make available for the small landowner treatment last year. So that will be implemented starting this year. And I believe that is my, well, second to last slide, but just to show the results of what, and once again, this is what we're looking at this year. This is what we were dealing with last year. So really good results. So finally, we're really trying to maintain that healthy forest economy approach, and build upon what we did last year. Roughly 70,000 acres, we're still dialing it in because every new sample that comes in gives us a little more or a little less for what needs to be treated. We're very close to having a kind of a final blocking here in the next couple of weeks. We're expecting application costs to rise slightly just because of everyone's favorite I word, inflation. And just the logistics of this year's program are going to be a little more difficult because we're not going to be able to just base out of one area. We're going to be likely using more helicopters and spread out in different regions. So we're going to continue to advocate and thank our federal partners. And then obviously we want to keep the continued communications going with our legislative groups and everyone else to make sure that we're saying what we're doing and doing what we're saying. So with that, I want to hopefully leave time for Patty. So I think that is my last slide. Yes, it is. So thank you.
Right, last but not least, great. Everybody's leaving.
All right.
Like I said, good to see you all, and just wanted to say that your assistance, your advocacy for this effort has been very welcome, and we've got folks here already introduced themselves from the Forest Service, but state entomologist Allison, if you have any questions, you can answer them. So the history, right? Just real quick, that Spruce Budworm is a partnership with spruce and fir, and has been for tens of thousands of years. It's in we're always going to be dealing with it. And I wanted to show you this image. So going back to years ago, just to show you the progression and how it built up, how bad it got in one of the worst infestations in the early 70s to officially, I guess, ending early 90s. And the point here is these images, what's happening here impacts what we're dealing with today. This is what set up the forests that we're dealing with today. So as you can see, this just takes a minute. It's just kind of festering a little bit. Northern Maine starts to get into the to the 70s and then really ramps up. And I'm sure you're aware that the spray program was quite extensive. So here you go, and you look at how vast, and compared to what you just saw Alex show and what we're dealing with now, this is look how much of the state. So most of the state. So jumping to, Alex talked about, the program last year and the coalition of landowners, and it's worked very well, named Forest Service, the landowners, the university, the Spruce Budworm Task Force. We've been working well together. So just wanted to show you as we go into spring, what the actual numbers are. And these are the funds that you folks advocated for. So in the 70s and 80s, the cost was over 75 million, and that translates to almost 300 million in dollars today. And it was mostly a program run by the state and different variations of funding as it went from 73 to 90s. And at one point, there was a tax on spruce fir stands and mixed wood stands. I think it was 16 cents per acre for mixed wood stands and 31 cents for spruce fir stands that landowners had to pay for this program. But there was also state and federal funds as part of it. So a much different atmosphere now as far as funding. So Alex mentioned the funds we got. We were allocated 2 million, thank you to the legislature for that, and state funding, 14 million in federal funds. 2 million of that went to New Hampshire for their efforts, and 500,000 of that went to the UMaine lab to support kind of growing this monitoring. And as you probably all heard, if there's no monitoring, there's no program. We have to have that monitoring. So around 10.2 million was expended for last spring's effort. As Alex said, a little over 240,000 acres treated. So this leaves 3.3 million, around 3.3 million for this year. And the effort is for small landowners. So maybe Alex has an update to this.
Hasn't signed it yet.
Okay, so the Interior Environment Appropriations Bill includes another 10 million, and yes, still waiting on the president's signature, which is always, you have to worry until there's a signature on it. Maine Forest Service will continue as of last spring to administer the funds. So just wanted to go over real quick that back in 25, very extensive outreach for the program overall. Lots of interviews, and Brittany is head of our communications and handled most of that. Lots of fact sheets, really, and Alex touched on it. Communications, it's all about communications, right? And folks understanding kind of what's going on. So again, lots of workshops and just a really big effort. Again, more of that. And if you there's multiple articles with Portland Press Herald, Bangor Daily News. And then of course there's a QR code that was set up for folks interested in the program. And of course, good old social media, right? So Facebook encouraged others to share the information. So the plan for 2026 for small landowners. So we've created a program for small private landowners under 4,000 acres in ownership. The goal, of course, same as you've heard already, to suppress populations using EIS. And as opposed to last spring, again, this is about small landowners. we did not have time last year to get together all the information needed for small landowners. So the overall goal is to prioritize treatments on woodlots, with the correct forest type and the, L2 numbers near or above the, threshold. Which has come with, many challenges. This has been, way more time invested, way more work than last year. As you can imagine, we're dealing with, a small landowner might be interested, but then they have a complete hardwood forest, right? So we have to figure out, meet with the landowner, check the boundary lines, verify the boundary lines, verify the spruce fir acreage, and see how it fits in the mosaic for being in the program. So 150 recruitment letters were sent to landowners with woodlots abutting those that had shown interest already. And the large landowners are also helping with this effort because they have these small landowners as abutters. And they were sent more information. So here, after months of recruitment, 29 out of 150, so pretty low numbers. There are 50 plus landowners, 125 woodlots submitted, which accounted for 10,400 acres. So now you're going into the assessment part of all those landowners. We have to check their acreage, their boundaries, what the composition of their woodlots are, and ownership, right? Do we even own the land? And so again, checking spruce fir cover and the L2 data, is it within the areas of high L2s? So now we go to today. So we had those 10,400 acres and we're down to about 70 woodlots. It's estimated that we're going to be treating around 3,500 acres of small wood landowners when it comes down to it. And this shows the area that those landowners are in. And this is just showing you that, I don't know how many of you have dealt with town tax maps, right? They're terrible. And it's not, I'm not throwing shade on anybody, but, so this is what we're dealing with, right? So we can't be spraying if we do not know for sure. Alex talked about the accuracy of those flights. So we need to bolster that with accurate on the ground information. So this is why it's taking a lot of staff time, is from Allison's folks and, including folks from our other divisions, from Robbie's folks, Morton's folks, is that they have to go on the ground, verify with the landowner. Hopefully they have a management plan so you can kind of see what's out there. Check the boundaries with the town maps. A lot of digital detective work essentially going on. So that is really what's taking all the time right now. And so if you folks know of landowners who are interested, we're still, even though the product has been ordered by now, we're still accepting landowners that are interested. And so it's about ongoing outreach. I asked Allison why was there hesitancy from landowners? Is it distrust of government? Is it, what's going on? And we don't really have an overall picture of that, of why we're getting kind of low sign up for this, but maybe it's a matter of going through a year of it and then landowners seeing it. Because certainly by treating small landowners, we're helping everybody keep the impact down. And that's really all I had. I just wanted to show you the numbers of what we're dealing with, and that we will that we will be treating small landowners going forward. And it's a good picture. This is what's been happening and what's been done, and it's been good collaboration and it's been working. So it's a good picture.